Welcome back. Let's get going here. Let me share my screen. All right, everybody can see the screen and can hear me, I assume?
Yes, Professor.
Okay, thank you. I always appreciate it when somebody responds like that. All right, let's first start out by taking a look at the teams that we have. Let me make this bigger so you can see it. So I've got 11 teams, and we have enough students to have about 15 teams. See if I can fit all the teams I have. Okay, so there's room for about 4 more teams, and I can arbitrarily assign students to teams or create new teams, or if you can get me your teams as soon as you can. If you don't know anybody, then I can just create teams out of the remaining students, but it's always best if you form your own teams. Okay, so if your name is down here, please let me know what the new teams are going to be. Okay, because your first assignment is or not your first one, but your next assignment, number 2, will be team-based. So we really need to get these set up before you start submitting. Okay. All right. So get that information to me as soon as you can, please. Okay. Okay. Whoops. Oh, wrong set of slides. I teach too many classes and always the wrong set of slides. Okay. All right, so this is kind of where we left off on Tuesday. I showed you sort of this high-level view of what a compiler is all about. There's the front end, the intermediate tier, and the back end. And I think you know what each of these components are here. I mentioned the intermediate code and the symbol table. We haven't really gotten into those yet. And then in the back end, we have a code generator, which can generate object code. For a compiler, it's going to be low-level machine code or assembly language. And for a converter, well, we're converting from one high-level language to another. So the object code here will be the program in the other high-level language. For example, you write a Pascal program, and we convert it to an equivalent C++ program. Okay, and then there's the executor, which is going to directly execute the program. Now all the back end uses will be the intermediate code and the symbol table. Okay, so whether it's an executor or a code generator for a compiler or a converter, each of these only make use of the intermediate code and the symbol table. Now, of course, what the executor is going to do is, based on the information in these two data structures, it will go ahead and execute the program. Okay. All right, so this is the high-level architectural view. And then, of course, we're going to write all this in our implementation language. For this class, that implementation language, the C++. And so I said that, well, we're going to take these tiers and make them into namespaces. So we have a front-end namespace, an intermediate namespace, and a back-end namespace. And each of the namespaces will contain the various classes, the parser class, scanner class, ICode, SymTab, backend, and so forth. Okay. Now the backend class, this is really a super class. There'll be an executor subclass and a code generator subclass, and so forth. Okay, so because a compiler is such a large, complex program, we really have to practice good software engineering practices. And one practice, of course, is to break everything up into manageable portions. And so here we have these 3 tiers and the 3 corresponding namespaces and the various classes that are contained in each of the namespaces. Okay. All right, so that's kind of where we left things off. And then I have a simple implementation of all this. Okay, it's not a full Pascal translator. I'm just calling it simple. And in the, well, there was the main program, which is just simple. There is the source and the scanner. And then there's a token. So these are the classes that we saw here, okay? And okay, so here, the whole purpose of the source class was basically, it represents the actual source file that contains the program, you know, your Pascal program or whatever that you're translating. And it has 2 important member functions. One that returns the current character. So, you know, the characters in the source are read one at a time. And you want to know, well, what's the character that was most recently read? That's the current character. And then you want to be able to get to the next character, so that the next chart function reads the next character and returns that character. Okay. Scanner, okay, remember tokens are these language components such as identifiers and numbers and keywords, or also known as reserved words. All the very special symbols like parentheses and equal signs and greater than signs, semicolons, colons, periods, all those special characters, okay? Those are all tokens of the language, okay? And the whole purpose of the scanner is to recognize the tokens in the source file, so that the parser that is in charge of the translation, it's the boss. It determines what's going on. Every time the parser says, "Hey, hey scanner, give me the next token," the scanner will then work with the token class and the source class in order to then extract the next token out of the source. And I showed you on Tuesday, character by character, how the scanner works. Okay, basically, if the current character is a blank, it will skip blanks all the way up to the first non-blank character that it encounters. And that non-blank character will determine what is the next token. If that character is a letter, then the next token is some sort of word. It could be an identifier or a reserved word. If the character is a digit, then, well, the next token must be a number. And if the character is, you know, that parenthesis, then obviously it's one of the special characters. Okay, so the scanner then, based on the first character of the token, will know whether it needs to extract a word or a number, etc. Okay, so that's how the scanner works. Okay, and you saw that in detail on Tuesday. Okay. Okay, and then we had the tokens. Okay, strings are tokens. I guess I haven't been mentioning strings. So in Pascal, a string is enclosed in single quotes. Okay, so that's just the syntax of the language. I know in other languages like C++, strings are enclosed in double quotes. Okay, so we have to know the syntax of the language. Okay. All right, so that is a token. Okay. Now, what we want to do, okay, before I show you your next assignment, is we want to test our scanner. And I think I showed you this, but let's do it again. Okay. So here is, I'm not going to call it a Pascal program because it's missing some parts. So we'll just say this is hello.text, txt. And I'm going to run the program simple, okay. It's named simple CPP because I have a Java version of this program also that I use for my other compiler class. When I run simple, okay, let me show you the run configuration. Okay. Okay. When I run it, okay, so there we go. Okay. Well, obviously, one of the arguments is the name of the source file, which in this case is hello world.txt. And then here, well, I'm actually not going to parse it. I'm going to scan it. Okay, so let me bring up. Okay, this is the one I really want. Okay, so one of the options is scan, and basically that says tokenize the input file. In other words, break it up into its various tokens and recognize what the token is. Okay, and so here, I think I showed you this. When you run this, okay, so here is the input file and here are the tokens. Okay, and so we have reserved words here, begin, program, begin. These are reserved words in the Pascal language. And of course, I recognize them as reserved words. Okay, so on the left-hand side is what is the token, and on the right-hand side is the actual characters that make up that token. Okay, so this is the reserved word program, and these are the characters that make up program. Okay, now hello world is not a reserved word, so we'll say it's an identifier. So that's identifier, and then here are the characters. Okay, and then we have a special character called semicolon, and so here it is semicolon, and here are the characters that make up the semicolon. Okay. So this was a little test of our scanner, and if if you look at the code, okay, it lives in the front end namespace, and okay, we look at the current character. Okay, so here we're telling the source object what is the current character. Okay, and if that current character, as long as it's a space, we're basically going to say, given the next character, given the next character. We're skipping over the spaces until we get to a non-blank character, which will be the first character of the next token. And based on that first character, if it's an alpha, okay, we go and get a word. If it's a digit, we go and get a number. If it's a single quote, we go and get a string. Otherwise, we're going to assume it's some sort of special symbol. Okay. And so we're asking the token class, okay, can you give me back that particular token? Okay, and we saw that the token class, okay, so here is word, okay, and so we basically create a new token. Okay, we initialize it with the first character, and as long as we're seeing more letters or numbers, remember, a word can be is a letter followed by 0 or more letters and numbers. We go ahead and get those characters and append it to the text of the token, and then we check once we have the word. Okay. Is it a reserved word? Okay, well, in our token class, we have this table. Okay, there it is. Okay, and we have some all the reserved words in here. Okay, okay. And so we check to see if it's one of those reserved words. If so, we say it's a reserved word. If it's not a word in that table, then it must be an identifier. So we just say, okay, it's just an identifier. And then we do the same thing with number. Okay, with number, we keep getting characters as long as it's a digit or the decimal point. Okay, because a number can have a decimal point. Okay, if it's a decimal point, we keep track of how many decimal points we saw. Hopefully, either we saw no decimal points or only one. Okay, if we saw more than one, then we're in trouble. Okay, now if we saw no decimal points, then it must have been an integer. Okay, and then we convert it to an actual integer value. So we have the digits that make up the integer, and we want to convert it to its integer value. And if there was one decimal point, then okay, it was a real number. Okay, and we convert it. Otherwise, well, there was more than one decimal point, we had an error. Okay. Okay, so that was number, and then string. Of course, we got the leading quote already, because that was the first character of the token, and we basically gobble up characters until we see the ending quote. Okay, so that was string. Okay, and then for special symbols, okay, well, there are special symbols, and we would just have to then go through and process them one at a time. And some of the special symbols, like colon, okay, it is a special symbol by itself, but there's also colon equals, which is a 2-character special symbol. And so we have to then check if we saw a colon, is the next character an equal sign. Okay, if it is, then the token, the special symbol, was colon equals. If the next character was not an equal sign, then it was just a colon by itself. Okay? So there are all kinds of little checks that we have to do. Okay. All right. So what I showed you here was a pretty complete version of the scanner. Now, the code that I'm giving you, okay, I want to make sure that I didn't give you the complete scanner by mistake. But your first assignment is to actually complete the scanner. Let me go to there. And okay, so this is Pascal scanner. Okay, now here are all the reserved words of the Pascal language. Okay, and here are all the special symbols. So you can see that colon is a special symbol by itself, but then so is colon equals. Okay, and the less than sign is special symbol by itself, but it could be part of this, which is the not equal to, or less than or equal to. Okay, so there are special symbols, and then these are token classes, identifier, a real number, integer number, and so forth. Okay, and so what you want to do is be able to read in. Here's another sample input file, and be able to recognize all the tokens, just as I did here. Okay, where I printed out, all the tokens and what each one of them is. Okay, and then so this is another fragment of a Pascal program. It's not a complete program. Okay, but to really test out the scanner, okay, here is sort of a nonsense input file, and that basically just has all kinds of tokens all mashed together, and if you do the scanner correctly, you'll be able to break apart this file and recognize all the tokens. And so here, if you give it this input, you should get output that looks like this. Okay. And notice that in Pascal, Pascal is a case insensitive language. Okay, so that means that each of these is the reserved word begin. So you can have it all caps, all lowercase, mixed all together. So if your scanner is smart enough, so you can see that here, okay, all 4 of them were recognized to be the keyword begin. Okay, the reserved word begin. However, the 5th one is not the reserved word begin, and it's just an identifier. Okay. Now, some of these combinations of tokens, of course, would never occur in a real Pascal program. But the whole point of this exercise is to see if our scanner can handle and is able to recognize all the tokens, no matter how they happen to be combined in the input file. Okay. All right, we have some bad tokens here. So here, look at this. Okay. Obviously, not a number with, and so here you can see. Oops, there we see we actually got an error message here. Okay, and then what? Now, what is recognized to be an identifier, but in Pascal, the question mark is not part of the language, and so that has to be flagged as an error. So here's a token error. Okay, doesn't know what that is. Okay? And then here we have a string that was not closed. Oh, I want to point out that in Pascal, if you want the quote character to be part of the string, now in a language like C++, you would quote the quote character by putting a backslash in front of it. Okay, in Pascal, you would have two single quotes in a row, and inside a string that represents a single quote. So here we have, okay, it's Friday. Okay, so it's Friday is the string, and inside the string is a single quote. And in Pascal, we do that by putting two single quotes in a row. So let's see if we recognize that correctly. Yeah, so here is the string. Okay, so the two single quotes together represent one quote character that's part of the string. Okay, otherwise, of course, the single quote characters are at the beginning and at the end of the string. Okay, so that's something that we have to watch out for. Okay, and then these are comments. Okay, comments in Pascal are enclosed in braces, and so according to the rules of Pascal, a comment and the end of line character is treated as a blank. Okay, so you can run a bunch of statements together and on one line, and that's perfectly okay to Pascal. But if you have separate statements on separate lines, well, because the end of line character is treated as a blank, then there's no difference between putting each statement on a separate line or running all the statements together on one line. Okay, so comments and end of line characters are to be treated as blanks. Okay, and you know that we skip over blanks as you saw. Okay, so when we put together a scanner, it has to have a little bit more intelligence than the simple one that I just showed you. Okay? All right, so for assignment number 1 then, there's a zip file, and let me make sure, because obviously I have a version of that has all the reserved words and special characters already in there. I want to make sure I didn't give that to you by mistake. So let's see, this is 152. And well, actually, let me actually download it just to be real sure. Okay, so Pascal scanner, and here is the zip file. Okay, there it goes. Let me unzip it. There it is, and let me check. Okay, so you can see that it has a back end, a front end, and intermediate. Now, most of your work will be in the front end, of course, since you're working with the tokens and the scanner. So let me check here, token.h. Okay. Okay, looks like I gave you the complete one. Let me make sure. How did that happen? Okay, let me, okay, I need to fix that. Gosh, I thought I checked to make sure I was giving you the right version, but looks like I gave you the version that had everything in it already. Let's make sure. Let me take a look at the, yeah, okay, all right. I screwed up. I gave you the solution. Okay, well, let me get rid of the solution right now. And then I'll upload the right version of that. Okay, let's see, assignment number 1, 2. Okay, there it goes. And, oh, that's interesting. It's, what did I do? Okay, now I don't see it up here. Simple zip. Okay, well, let me take that out for now, and then I'll upload the correct version that you need for the assignment. Okay, yeah. Which is basically to fill in the rest of the reserved words and the remaining special symbols. Okay, it's just an exercise to make sure that you understand what tokens are and how the scanner works. You're going to have to put in the extra logic that says that if there are 2 consecutive single quotes in a string, that represents a literal single quote that belongs to the string itself. If you see comments or end of line characters, that's supposed to be treated as a blank. And so there's a little bit of extra logic in there. Okay, and so this is an exercise in learning how to write a scanner. Okay, and then we'll move on to writing a parser. Okay, all right. Sorry about that. I thought I checked everything last night to make sure I was uploading the correct thing, but okay, too many things going on. Okay, we had a department meeting yesterday where they were discussing what happens in the fall. You know, are we all going to be back on campus? Will we all be vaccinated? If we're back on campus and we're all crowded together in a classroom, do we all still have to wear masks? So there are a lot of issues floating around as to what's going to happen next fall semester. And that's quite a distraction thinking about that. Okay. All right. Any questions at all about scanner? Okay, so you can add these reserved words and add the rest of the special symbols. Okay, and that's your first team-based assignment. That's assignment number assignment number 2. Okay. Oh, how did we do on assignment number 1? Everybody managed to get those Pascal programs running? And any issues with the Pascal programs? Okay.
Yeah, part three's was kind of hard when it came to separating the data. Like, one of the things I wanted to do was take the first 4 characters of each line, because each line had the year, and separate that from the rest of the string. But I can't do that with, let's say, an array of strings. Pascal has this feature where you can take individual characters of a string, but you can't do it, let's say, within an array of strings, which was kind of annoying.
Okay, well, so in the input file, there were these numbers, right? And the numbers were separated with at least one blank. Well, let me make sure I'm saying all the right things here. Right, so. Okay, so this was the input file, and these are the numbers you're talking about, right? The years. Okay, well, all you had to do was say read with integer variable, and the read function knows to read a number, and because there's a blank separating the number from everything else, it knows to read 2009, and then you have another integer variable, and you say read, and it would have read 2017. Okay. Now then, reading the name, you will probably have to go character by character, but reading the numbers is just a simple read statement. So let me see. Yeah, I explained that right here. Okay.
Oh.
So that should have made your program a lot easier. Okay.
And for the Sentinel, the -1 Sentinel, it never seemed to work for me. I don't
Okay,
know.
well, so when you read each line, okay, the first thing you read would be the beginning year, right? And so if you just, okay, so you first, okay, for each one, you read the beginning year, you read the ending year, whoops, ending year, then you read the president's name, okay? So now you're done with that input line, and you start to read the next line, and again, you'll get the beginning year and so forth. But then let's say here, you're done with George W. Bush, and you read the next input line, and you're trying to read the beginning of year, and you get a -1. Well, then you know that you're done reading the all the presidents. Okay, and the same thing down here. Okay, you have a loop that's reading in these years. Okay, and you just do it this way, and when you get to a year that's -1, then you know you're done reading the years. Okay, so
whenever I got to the -1 part, right,
yeah.
and I read the next line, for the next line it shows everything as 0. So if I print out or read the next integer after -1, first
Oh,
it shows as
okay.
0.
Okay, so you've read, okay, you've recognized the -1. So now you know you're done with the presidents, right?
Yes.
And then you want to start reading in these, and you're just getting zeros, you said.
Yes. So I read to a new line, so I can I go away from the -1 line to the
Oh, okay, so
next
you
line,
call
and then,
read line. Okay, so you do this, and then you start reading numbers using,
but the numbers are zeros.
they're all zeros. Oh, that's very strange. Okay. I'll have to look at your program then to see what could be going wrong. All right, would it help if I, since I haven't posted my solution, would it help if I gave you, say, a weekend to figure all this out?
Yeah, sure, that would be pretty nice.
Okay,
That would
okay.
be great.
So, all right, so get your solutions to me by end of the weekend, and I'll tell the grader not to take off points for being late. If you're getting weird issues like reading all zeros, yeah, I'll have to look at the program. So let's see. I normally would like students to bring up these kinds of issues in the discussion, so that other students can look and maybe answer the question, or everybody can see the same answer. Yeah, if you can post the statements that are relevant to that part, or maybe post enough so that people can tell what you're doing, and maybe we can spot what's going on. Okay. You might take out the read line, because remember, a line feed end of line is treated as a blank. So after you've read the -1 and you do another read of an integer, you should be picking up the 1975. So try taking out the read line and see if that helps.
Okay, I'll look into that.
Okay. All right, so I guess I won't be showing you my solution, and I need to fix the obviously I need to fix the program for assignment number 2. So I need to post that. Okay, I don't know what happened here. I thought I had posted the right thing, but I see that evidently I didn't. So I will get the right thing up there, and then you can go in there and finish it. Okay, I already kind of showed you how to put in the rest of the reserved words, so that should be easy. And then you have to work out the logic to pick up all the remaining special symbols, and knowing to skip comments and end of line characters. Okay, all right, so that's assignment number 2. And okay, so and I did put up I did post another fragment of a Pascal program for you to test, and then there was that file that had all the tokens mashed together, and see if your scanner can handle that. Okay. All right, I want to show you some more syntax diagrams, and I showed you some on Tuesday that basically described the tokens. Okay, you saw a syntax diagram for word, a syntax diagram for a number, and the syntax diagram that said what a letter is and what a digit is, and so forth. Okay, now these are slightly higher level syntax diagrams. This one says what a statement is. Okay, so a statement in Pascal is either a compound statement or an assignment statement. Okay, now, obviously I've left off a bunch of other statements, but for the purpose of this diagram, we'll just consider these two. Okay, now a compound statement then is made up of the reserved word begin, followed by statement list, followed by the reserved word end. Okay, so you've already seen this. Okay, so here is okay. Here's begin and end, begin and end. Okay, so in languages like C++, of course, we use curly braces instead to mark the beginning and at the end of a statement list. But in Pascal, it used the reserved words begin and end. Okay, and of course, the curly braces were used for comments. Okay, all right. So this is the syntax of a compound statement, and again, the rounded boxes represent, sort of the either a literal character or a reserved word. Okay, so begin and end are reserved words. Okay, and here around the box for literal characters. Okay, and a square box, a rectangular box, refers to another diagram. Okay, so here is a compound statement. Okay, and it's referring to statement list. Okay, well, what's a statement list? Well, here's a statement list. Okay, statement list is a single statement. Okay, or it can be a list of statements separated by semicolons. Okay, so it's either a single statement, so you come in one statement and then you're done, or it's one statement, semicolon, another statement, semicolon, another statement, and so forth. Okay, so that's a statement list. Okay, now looking at these diagrams, you're going to see one big difference between Pascal and languages like C++ when it comes to semicolons. Okay, in many languages like C++, a semicolon is used to end a statement. So a statement will have a semicolon at the end. Okay, in Pascal, a semicolon is used to separate statements. Okay, so if you have only one statement, you don't need a semicolon at the end. Okay, but if you have more than one statement in a list, you do put in a semicolon to separate them. Okay, now that may be a very, very subtle difference, but when you're going to write a compiler and the compiler has to know the syntax of the language, then these little subtleties have to be known by your compiler. Okay, all right, and then assignment statement. Okay, well, what's an assignment statement? Okay, assignment statement has a variable, colon equals, and then an expression. Okay, and what's a variable? Well, a variable is an identifier. What's an identifier? An identifier is a word. Okay, and then in earlier syntax diagrams, you saw the diagram for a word. Okay, so again, these diagrams are very simplified because we all know that variables can have subscripts and so forth. But here we're just going to say a variable is just a word. Okay, and then we have to know what an expression is, right? Okay, so here's an expression. All right. Well, expression gets a little bit more involved. Okay, and so an expression can be just a single simple expression. So you just come in, simple expression, and you're done. Or an expression can be a simple expression followed by one of these relational operators, followed by another simple expression, and then you're done. Okay, so an expression is either one simple expression or two simple expressions separated by a relational operator. Okay. So then say, well, what's a simple expression? Well, simple expression is, it could be just a term, because they follow this term and then you're done. Okay. It could have a leading plus or minus sign. Okay. Or it could be a term followed by one of these operators, plus, minus, or, and then another term, okay? And then there could be more, okay? So you could have a whole series of terms separated by either a plus sign, minus sign, or the reserved word or, and then you finally, when you're done, you go out, okay? All right, so that's what a simple expression is, and you can think of simple expression as dealing with the additive operators, so plus, minus, and or, okay? Are considered the additive operators. Okay, and a term can be preceded by plus or minus sign, for negative or positive. Okay. All right. So what's a term? Well, a term is a single factor. So follow this, and up you go. Or it's a factor or a string of factors, round and around here, separated by the multiplicative operators. Okay, multiply, divide, div, mod, or and. Okay, now slash is for doing a real division. Okay, so you can say 1/3 and get 0.323 and so forth. Div is integer division. So if it's I don't know, 7 div 2, you get back 3. Okay, so that div will give you a truncated integer result. Mod is for modulo or rem in languages like C++. This is the percent sign operator. In Pascal is the mod reserved word, and of course is for ANDing relational expressions. So these are considered the multiplicative operators, and that's what a term is made of. Okay. All right, finally, what's a factor? Okay, well, a factor could be a variable. Okay, it could be a number, it could be a string, it could be not another factor, or it can be a parenthesized expression. So of course, expression then takes you all the way back up to here. Okay, so this is all very recursive, the way these diagrams are defined. Okay. Now, these diagrams only give you the syntax, not necessarily the correct semantics. So a factor can be a string, but in Pascal, if you say string divided by another string, then that's still an error. Okay, so these syntax diagrams don't give the complete rules of the language, but they will give you the syntax, okay? Later on, we'll learn that there are syntactic rules and semantic rules, okay? So trying to divide one string by another is a semantic error, okay? But these are syntax diagrams, okay? Well, we'll learn more about the distinctions later, okay? All right, so now we have more diagrams, and these diagrams are actually a very nice way of visualizing the grammar rules, well, the syntax rules of a language, okay? They're a bit painful to draw. I used a drawing package to do these, but later on you'll see that there are automatic drawing programs that will draw these diagrams for us. Okay, so don't worry too much about, oh gosh, I'll spend hours drawing these diagrams by hand. You won't have to do that. Okay, I mean, I spent hours drawing these things, but that was because I wanted nice slides to look at. Okay. All right. Any questions at all about these diagrams? Okay. They're also known as railroad diagrams because they kind of look like train tracks and switching yards and so forth. Okay. But I just call them syntax diagrams because they do show the syntax rules of a language. Okay. All right, if there are no questions, these diagrams are going to be very, very useful throughout the semester. So let's make sure we can understand how to read them. Okay. All right, now Pascal does have precedence rules. Now, Pascal keeps it fairly simple because one of the reasons I picked Pascal as our source language, there are only 4 levels. I believe in C++ there are like 7 levels of precedence, but okay, here are the 4 levels. Okay, highest level is not. Okay, so if you see a not in an expression, you're supposed to deal with not first. Okay, then there are the multiplicative operators. So of course, multiply and divide will happen before the additive operators. So here are the additive operators. And at the lowest level, okay, you deal with these last are the relational operators. Okay. Now, if you have an expression with no parentheses in it, then you have to make sure that you do all the operations in the right order. Okay. Now remember that the factor, okay, factor being at the highest level, remember factor was where the parentheses live, okay? And so that tells you that if there are parentheses, you're supposed to deal with the parentheses first. And if there are nested parentheses, you work with the parentheses from the most deeply nested first, and then you work your way out, okay? So that, these are rules that you're probably already familiar with, except that in Pascal, there's only 4 levels, whereas in other languages, there are more levels. And in fact, I always tell people, use parentheses. Now, don't rely on your memory of what the precedence levels are. Just use parentheses and you'll be sure, okay? All right, so we do have operator precedence rules, and just as an illustration, okay, here is an expression, okay. It's got multiplicative and additive operators, and it's got some parentheses, and based on the syntax diagrams that I showed you for expression, simple expression, term, and factor, here's how you would decompose, okay, this thing. So the whole thing, of course, is an expression. So there is expression in this big black box on the outside, okay? Now this expression turns out to be made up of only one simple expression. Remember, an expression can be a single simple expression or 2 simple expressions separated by a relational operator. Okay, well, there's no relational operator here, so it's only one simple expression. So you see this white box out here. Okay, now inside the simple expression, we have three terms. Remember, terms handle the or our simple expressions deal with the additive operators. So this simple expression has a term plus another term plus a third term. Okay, so we see in the gray boxes here, we've got three terms. Okay, now the first term is alpha. Okay, well, a term is made up of factor. Remember, the factor takes care of the multiplicative operators. Well, there's no multiplicative operator in here, so it's only one variable, and the variable is alpha. Okay. Now, the second term here does have a multiplicative operator, the slash. You see, here it is. There's a slash. Okay. The first factor is just a number, 3. And the second factor, well, we have parentheses in the second factor. So here are the parentheses of that factor. And what's inside the parentheses? Another expression. So again, we go expression, simple expression, and then the simple expression has two terms. Here's the term for beta, here's the term for gamma, and here's the minus sign. And then finally, the third term out here is just the number 5. Okay? So based on the syntax diagrams for expression, now this is how we would decompose this expression. Okay. Now, why did I show you this? Well, I want you to see, expression, simple expression, term, and factor. But this decomposition is something that the compiler will have to do. In the front end, the parser, when it's getting these tokens one at a time from the scanner, has to be able to figure out that, oh, this is an expression. This is how I break it up into simple expressions and terms and factors and so forth. Okay, so I've shown you the result of a decomposition, but that's something that the parser will know how to do. Okay. All right, any questions at all about syntax diagrams and expressions? Okay. All right. Now we have various control statements in Pascal. There's the repeat until, which in C++ is the do while. We have the while do, the for, do, to, and for down to. So in a for loop, you can count up or you can count down. Okay. And in Pascal, you can only count by 1. So you can go 1, 2, 3, 4, 5, or you can go 5, 4, 3, 2, 1. Okay, count up or count down. There are conditional statements. There's the if then else statement. And then there's the case statement, which is equivalent to the switch statement in C++. Okay? So you can kind of see where the more modern languages have evolved from some of the concepts in Pascal. And remember, Pascal was a language that came out in the 70s and became very popular in the 80s. And you can see that the ideas behind the various looping statements and the various conditional statements ended up in languages like C and C++ and so forth. Okay, so there's some historical significance to Pascal. Okay. All right, so now we can expand our syntax diagram. So remember, the one that I started out with for a statement only had these two. Okay, well, now I've shown you some other statements. And so now you can say a statement, a compound statement, assignment statement, or any of the other statements that I showed you. Okay. All right, so, and then here's a syntax diagram for the repeat statement. There's a repeat and there's an until. So in between repeat and until is a statement list. Okay. And then here is an expression. Okay. Now, you and I both know that that expression has to be some sort of Boolean expression that returns either true or false, okay? But again, the syntax diagram will only say that it has to be an expression, okay? So somewhere later, the parser will then check to make sure that that expression is indeed a Boolean expression, okay? But the syntax diagram, we keep it at a very high level, okay? So, all right, so this is an example of the repeat statement syntax diagram. And we can easily draw syntax diagrams for the other statements. And in fact, later on, you will see more diagrams, okay? But I want to show you parse tree, okay? Remember that in the intermediate tier, you have the intermediate code and the symbol table, okay? Now, the intermediate code can take various forms, and in this class, it's going to take the form of a tree, okay? And so this is a little fragment from Pascal. It's obviously a compound statement that consists of 3 assignment statements, okay? And you can see that when we translate, or when the parser then reads this and builds the parse tree, this is what the parse tree is going to look like. And so I just have a very high level diagram. You can see that the root of this parse tree is a compound node because it's compound statement. And the compound statement is made up of 3 assignment statements. I've got these 3 nodes here labeled assign. And well, let's take a look at the second one. Beta gets the value 99. Well, then the first child of the assignment node is the variable beta, and the second child is the integer constant 99, okay? And then, okay, now let's look at the first one. Here's alpha gets the value minus 88. Okay, well, the first child is alpha, okay? Now the second child is, there's a negate node here, and then the constant 88. Okay, so when the parser has figured out that this is an assignment statement, it will build this little tree here, okay? And then the third assignment, okay, we can see that things have gotten a little bit more complicated. There is our favorite expression. Okay, so here, the third assignment, well, the first child, of course, is result, okay? And then we have an add node. Well, what are we adding? Well, we're adding, okay, well, we can see that the last child, the second child of this add node is the 5. So there's the 5, but the first child is another addition. Okay, so it's going to be for this addition, and here the first child is alpha, and the second child of this addition, well, we see that there's going to be a floating division. Okay, and then the first operand of the float of the divide is the 3. So here's the integer constant 3. And the second operand is this expression. So it's a subtraction, and is beta minus gamma. So here's the subtract node. First child is beta, second child is gamma. Okay? So this is an example of intermediate code in the form of a tree, a parse tree. Okay, and so in the front end, when the parser, which is in charge of the whole translation process, and you saw in our diagrams that the parser creates the intermediate code. Okay, so when the parser reads this, okay, remember, is calling the scanner for each of these tokens. So it's getting these tokens one at a time, but then it has to recognize that, oh, this is a compound statement, and here are 3 assignment statements, and here's an expression, etc. So as the parser is translating, it's going to then build this parse tree, okay? And then, of course, in the back end, the code generator or the executor will then get a hold of this parse tree and then do whatever the backend needs to do. Okay, so this is a parse tree. Okay, and you know, you've all taken the data structures class, so you know what a tree data structure is, and so there are various operations that you want to be able to do with this tree. Create a new node. Sometimes you may want to create a copy of a node. You want to get and set the root of a parse tree. So here, of course, the root of this parse tree is compound. You want to get an attribute value of a node. So here's a variable node, and one of the attributes is the name of the variable. Here's an integer constant node, and okay, what's an attribute value? Well, here's the value 3. So the nodes can have attributes, okay? You want to add a child node to a node. So here we have the float divide, and we needed to add this child, and we had to add this child here to that node. So we want to be able to add child nodes. Okay. If we have a node that has children, you want to be able to get a list of the children. So here, okay, here is compound. Okay, well, what are the children of the compound node? Well, it's these 3 assignment nodes. Okay, so given a node, we want to be able to get a list of its children. Okay, and then given a node, we want to know what its parent is. So okay, if you're given this node, what's the parent? Well, then you want to be able to say that the parent is the compound node. Okay, so these are very, very basic tree operations, and given that our intermediate code is going to be in the form of a parse tree, then we will be doing those operations. Okay. All right, so now we can take a look at the parser. Okay. We've been concentrating on the scanner and on the tokens. Okay, what's the parser going to be like? And you can see that inside the parser class, there are lots and lots of these member functions, and there's one for each type of statement. So here's parse program to parse the entire program, parse statement, parse assignment statement, parse compound statement, parse repeat statement, and so forth. And then there are these parsers for each of the parts of an expression. Okay, parser for getting an integer constant, real constant, and string constant. Okay, so the parser is then made up of a number of these parsing functions, one per, I guess, language element. And so you see the various statements and the various parts of expression and so forth. Okay, and they call each other, of course. Parse statement will then call parse assignment statement, and parse assignment statement will have to call parse variable, and it will also call parse expression and so forth. Okay, so many individual member functions. Okay, now you can see how those syntax diagrams are useful. Okay, because based on the syntax diagrams that I showed you, we can come up with these parsing functions. So we know that we're going to need to parse repeat statements because we saw repeat statement in the syntax diagram. And so here is parse repeat statement. Okay, we're going to be parsing expressions, and expressions made up of a simple expression, term, factor, etc., etc. And so we know we're going to have to write a parsing function for each of those. Okay, so you can see that those syntax diagrams help us to determine what the parser has to do. Okay, because again, we're still in the front end namespace. Okay. All right, so we have a whole bunch of these parse member functions, which I just said parse star. And what does each one of them do? Well, each one of them will build parts of that parse tree. Okay, so each one will build a subtree and return the root of that subtree. Okay, so so each of the parse functions will build a little part of the parse tree, return the root of the subtree that it built, and then these subtrees are assembled into the entire parse tree. Okay, so all right, so if you call one of these parse functions, you will get back the root of the subtree that function built. And then if you're the caller, you will then take that root and make it part of the larger subtree that you're building. Okay, so the trees are built incrementally. Okay, and this process keeps working until the entire tree is built. Okay, so the tree is kind of built from the bottom up. Okay, the parsing routines will build the bottom part of the subtree, and then those subtrees are made part of a larger subtree, and you work your way up until you have the entire parse tree. Okay? And I'll show you how that works. Okay. All right. So here are a couple of simple assignment statements in Pascal. And okay, so now obviously this is a compound statement, and so parse compound statement is called. Now, parse compound statement is one of these guys. Okay, and so it goes and creates a compound node. Okay, because that's going to be the root of the compound tree. Okay, and then it's going to call parse compound statement is going to call parse assignment statement, because the first statement in the statement list is an assignment statement. Okay. Well, what does parse assignment statement do? Well, first thing it will do is create an assign node. Okay, and then it has to deal with the left-hand side, which of course, for an assignment statement, it's just a variable. So then it will create a variable node as the first child of the assign node. Okay. Oh, I should have pointed out that terminology that often is used is adopt. Okay. So instead of saying that, okay, the assign node creates a child node called the variable, then terminology says the assign node adopts a variable node. Okay? That just means that it's making the variable node a child. Okay? All right, so the parse assignment statement, first thing it does is create the assignment node and then adopt a variable node to represent the left-hand side, which in this case is alpha. Okay? Well, now it has to parse the right-hand side, okay, which is an expression. Okay? Now, in this case, it's a very, very simple expression. It's just the number 10. And so we will adopt a integer constant node. And so parse expression will then end up creating only integer constant as a node. And then that node is adopted by the assignment node. And so now the assignment node has its two children. Okay. Now then, when we return from parse assignment, okay, parse assignment will return a pointer to, will return a pointer to the assign node. And well, who called parse assignment? Well, it was a compound statement that called parse assignment. And so it will then take the assign node and adopt it. And so now we have this much of the parse tree. Okay. All right, well, we're back in parse compound, and we're ready to parse the second statement in the list. Okay, and the same thing happens. Okay, it calls parse compound statement calls parse assignment statement, and we end up with this tree. Okay, and that gets adopted by compound, and so now the compound tree is finished. Okay. Now, of course, this compound statement could have been part of program, or maybe this is part of a while loop. And so you can imagine that whoever called parse compound statement will then get the root of the compound node, and then that gets adopted into a larger tree that's being built. Okay, so this is how a parse tree is built from the kind of from the bottom up. Okay, incrementally. Okay. All right, so now we have to take a look at some other classes. Now the parse tree lives in the intermediate tier, and so now we're looking at namespace intermediate, and you can see that, okay, there are various node types. There's program node, compound node, add node, subtract node. You've already seen some of these nodes in the trees that I've shown you, okay? And if I'm going to build a tree, then I want to be able to print out the tree so that I can make sure that my parser is doing the right thing. It's a little bit hard to print out a tree in this graphical form. And so instead, I print out the tree in XML format. So instead of this nice graphical representation, this is what I actually will print out. Okay, so you can see this compound is made up of 2 assigns, and each assign has a variable and a constant, variable and a constant, and so forth. So this is how I will print out a parse tree. Okay, so let me show you. Okay, so here we go back to my simple. Okay, now instead of just showing off the scanner, I'm going to now show off the parser. And so let's do that. So now I'm going to parse hello world.txt, and there's the parse tree. Okay, so okay, let me bring up hello world. You can see that the entire tree is a program. Okay, so program, and then the program has a compound statement. So here's the compound statement at line 3. So one of the attributes of the tree node is what line number. And then the first is an assignment. Okay, I gets the value 0. And then I have a repeat. Okay, so the repeat I do as a loop. Okay, so here is, that's the loop. And then the first thing in the loop is this assignment, and there's I+1 here. You can see there's an add here, I+1, and there are some write statements. And so you can see there are a bunch of write nodes and write lines, and oh look, there is a string, couple of string constants here. There's that right here, and then there's this string. So you can see that we have some string constant nodes. Okay. And then finally, there's a test, okay? And what are we testing? We're testing to see if I is equal to 5, and that is an equal. So in Pascal, a single equals is the relational equals, okay? It's equivalent to the equals in C++, whereas the assignment is colon equals, okay? Okay, so here this is an equality test of 5 and the integer constant I. Okay, so you can see that the parser then in the front end has built this parse tree in the intermediate tier. Okay. All right, so this is a illustration of what the parser is doing, is building this I code in the form of a parse tree. Okay. All right, let's finish up here. Now, the other component of intermediate tier is the symbol table, and I don't think I'm going to have time to talk about symbol table. So let me end it here, and we'll pick up on symbol table when we come back next week. Okay, but I will then. I will have to upload the correct version of simple.cpp for you to use for assignment number 2. Okay, and I'll extend assignment the due date for assignment number 1, the Pascal programs, until Monday. And it's important that you have at least a working knowledge of Pascal, because I'm going to be using Pascal as the example source language throughout the semester. And if you don't know what the Pascal program is doing, it's going to be really hard for you to understand what the interpreter is doing or what the code generator is doing and so forth. Okay. All right, and any questions? Okay. I will be having my office hour at 4:30. So if you want to come in and meet with me privately, you can do that too. Okay. All right. I see there are lots and lots of chat messages. I hope they weren't. Whoops. What is that? Hope they weren't something important that I needed to. Oh, okay. People are using Turbo Pascal. Wow, that is a very, very, very old program. But if you can get that to work, that's fine. And okay, so I think it's safe for me to go ahead and end the class. If you have any questions about the assignment, whether it's the first one or the second one, please use the discussion feature. Okay. All right. Any questions? If not, then
I have a quick question.
a quick question. Yes.
So the second assignment will be still due on 11, right? Or
Yeah. It's not that hard. You're basically just taking what I give you and adding more logic to it.
okay, I got it.
And it is team-based, so you'll be able to work together with your teammates on that one. Okay.
Okay, I see. Thank you, Professor.
All right. Anything else? Okay, then I will end the meeting.